So we are starting with our Scratch project, which is our rock, paper, scissors. So let's go to create, and this is Scratch 3.0, which is the new version, which is very exciting. So we are in the Scratch 3.0. We have our script view, we have our stage where we are going to build stuff. We also have we are clicking on the Spanish version, so you can see the Spanish commands, which is very helpful for families and students. You can, of course, switch back to any other language. We're switching back to English, but you can choose any of the languages, which is very helpful, especially when you're working with students who speak different languages, or families, especially. If you have a family computing academy or a camp, you could be using that. So right now we are going to name our file. In this case, it's RP Rock Paper Scissors, because that's the project that we're working on. We already have a sprite. And since we are working on the rock, paper, scissors challenge, we're also going to look at the plan that I have devised for this project. We're going to create a very basic project where two characters will start. One will start at the left, the other one will start at the right edges of the screen. They will meet in the middle and they'll play a game of rock, paper, scissors. One of them will be a winner, and that winner will jump up and down and will say, I won. So that's sort of the basic animation that we are going to start with, which will be a nice project template for your students to start with. So let's begin. We are going to name our project. We already have one sprite, and now we are going to create another sprite. We can choose from the existing collection of sprites that we have. We can paint a sprite. There's also a surprise, or you can upload a sprite, which is essentially an image that you upload that you would like. In this case, I'm going to choose a sprite. So I'm going to go into the library. My first sprite is a cat. So I'm going to look for another sprite that can play rock, paper, scissors with my cat. So let's see. A dinosaur would be great. What I'm looking for right now is a sprite that's looking in the opposite direction, so that eventually we can also work on the command towards turning the cat or turning the sprite that we choose towards the cat. So that would be an additional challenge. So I chose duck, which is actually looking at the opposite side, which will give us an opportunity to play with the code and work on sort of turning him around so that they can interact. Okay, so we are going to place our sprite. One of the things in Scratch is that we have a grid. We have an XY coordinate system where X is our horizontal, Y is in our vertical. X goes from minus 240 to 240, so that means there is 480 pixels, while as in case of Y, you have minus 180 to 180 pixels. So essentially, by choosing the X and Y coordinate points, you are mathematically deciding where your characters would be placed, or in this case, the sprites would be placed onto the screen on the stage, and you can create your animation. So let's go back to our Scratch animation and see how we can build our cat's movement, which is our first sprite. So let's look at our cat sprite, and in this case we are going to move our cat sprite by 10 steps. So let's click on our move command and see what happens. So cat is moving by 10 steps, and we can keep doing that. The other way we can make our cat move is through the go to command. So I'm going to go back to my cat, and I'm going to pull in the go to command onto my stage. So let's say go to minus 181 to Y minus 121. And when I click on that, it's not going to move the cat because that's its position, but I'm going to move it to X 100, and let's say Y to minus 84. Let's see what that looks like. It's actually moving cat in an angle. So I'm going to put it back to, let's bring the cat down, and it looks like it's minus 130. So I'm going to change the coordinates to minus 130-ish or 131. And let's see, let's bring back the cat to its original position. And then let's click on our go to command, and it will move our cat to, give me a quick second, we're going to put minus, yeah, that's how we wanted to do this. So it's moving from coordinate x equals 100 to y equals minus 123. Now I'm going to duplicate my go to command so that I can bring the cat back to its original position. So I'm going to put minus 100, and let's see what that does. So that's good. But as you can see, it's almost like the cat is teleporting from one point to the other. You don't really see the motion. So now we are going to choose the glide action command, well, motion command, which will allow us to see the cat move from, say, minus 100, or in this case, 100 to minus 123. And you can see the gradual movement of the cat, or cat gliding onto the screen. So that's a nice one. We are going to duplicate our glide command, and then we are going to add minus 100 to, let's say, and let's see what that does, bringing it back to the original position. And you can see the movement of cat going back and forth, which is a nice way of looking at it. Now we're going to add a repeat command to our move, so that we can achieve the same effect. So in this case, we'll have to repeat it 20 times, because between 100 to minus 100, we have x has to travel between 200 pixels. So that is going to give us the movement. We will have to repeat the, we'll have to duplicate the repeat command. So I'm going to do that. For duplicating, I'm right clicking and duplicating. So in this case, we do minus 10, we duplicate, and this looks great. It's almost identical to what we've achieved with our go-to as well as our glide. But in go-to, in order to see the motion, now we're going to add a wait between the two go-to commands, just so that we can see some motion as opposed to the teleportation effect that we are seeing. So let's add wait in between our go-to commands. This one is a wait with a conditional, but we don't really want a wait with a conditional. So we are going to add a wait with, say, 1 second or 2 second delay. So let's try to do that. I'm going to move the wait block back and add the wait 1 second block. And let's see what that does. It'll at least show you some sort of a movement, yes, between the two go-to commands, which is the wait of 1 second. So this is sort of all of the basic move commands, which is going to allow us to fulfill our first objective, which is moving the sprite from, first sprite from left to right, and into the middle of the stage, where he's eventually going to meet with the duck. Now what I'm showing you are the x and the y coordinates on the screen, and as I move my cat around, you'll see the x and the y coordinates changing onto the screen. In this case, you will also see them changing into the motion blocks. So I can actually place my cat right at the beginning, and I will be able to see the x coordinates. And if I move my cat to the middle of the stage where I want it to move, I should be able to see the x and the y commands, x and the y positions for that as well. So I'm going to get rid of all the code on the stage, and now I'm going to plan where I want my cat to start and where I want my cat to stop to meet the duck. So in this case, my cat is starting at go to minus 186 to minus 117. And then I'm going to get the go to of my middle point of the stage, and then I'm going to add a wait in between. But instead of the go to afterwards, I want to see the motion. So I'm going to add a glide command. And let's get the glide command right in there. Let's get rid of that go to. And in this case, let's click and see what happens. So you can see that our cat, let me see what's happening here. Our cat should be moving to the center of the stage. So I'm going to click out and then I'm going to try to do that. Yep, now it works. That's great. I am going to test it out one more time. Wonderful. So I'm going to move that code now into the duck sprite. And to do that, I'm just going to drag it over the duck sprite. There is no real announcement that the code has been added to the duck sprite, but you can see that it is. When you click on the duck sprite, you can see that it's in the script section. So now we're going to place our duck where we want it, which is the further corner. We have our X and the Y in this case. So we are going to get the go to um, X and the Y for that. So we're going to drag the go to block onto the screen, which will be 181 to minus 109. I'm going to place it right at the top, and I'm going to make it minus 181, and then we don't really need 109 there, but let's see what it does. Interesting. So I would like to get rid of the other go to. Let's see what that does. It's actually going to bump up the duck to the positive y, which is plus 109, which is not something we want. So I'm going to, we want our duck to end at this point. So I'm going to get the glide for that point. I'm going to get rid of that glide. Add this glide right after our wait command for minus 112, and we'll see what happens. So the duck rightfully jumped at the top and then is getting back to the middle, which is a great thing. Now we just need to change the X and Y coordinates for the duck to start at the endpoint. So I'm going to get rid of that go to, put in the go to for 193 and minus 113. Now it should give our duck enough time to get to the middle, and the motion seems very smooth. However, I don't want the duck to come into the middle and hit the cat. So I'm going to play with the X and the Y coordinates just to see what I can change in order for duck to stop right before sort of colliding into the cat. So let's see what that could look like. I'm going to keep playing with some of the values. Again, at a later stage, we would like, this is because this is the 3 to 5 age group, variables would be eventually introduced in this equation so that we are not actively changing the number of values, but we would be changing the variable that would be introduced. So right now, as you can see, the cat is colliding into the duck. So I'm varying the values for X and Y, and you can see that now it looks fairly good. The cat is stopping right in front of the duck. And this is a nice point where, the cat could say rock, paper, scissors, and they can play a game. So this looks like a nice X and Y coordinate that would allow us to proceed. The one thing that bothers me in this case is that the duck is not really facing the cat, and we would like to do that. So there are a few commands that would help us achieve that. So right now our cat and duck start from at different points and are meeting in the middle. If we want both of their actions to be triggered at the same time, we need to have a command that would allow us to do that. So in order for us to do that, we are going to go into the events, go to, yep, we're going to go to the events, and we are going to click on when green flag is clicked. So you're going to bring that into both the sprites. So let's look at the oh, but before that, we want to turn the duck. So let's turn the duck. For that, we are going to use a set rotation style. And set rotation style allows us to move it left to right, which is what we are going to use. The don't rotate obviously would not allow the duck to rotate. And you will see, we'll use the all round option just for you to see what it would do. So let's add the set rotation style to our duck code and see what happens. This technically should allow the duck to turn, but since it's not allowing it, there is a command called the point in direction, and we are going to put -90 in here so that you can see the duck turning and actually saying hello to the cat. So let's see now. Perfect. It is going to change the duck's position right at the beginning, and he's approaching the cat, possibly saying hello. Now, if we choose the don't rotate option, you can see that it's really not rotating the duck. And now we are going to go around and play with the all round option. You can see that the duck actually flips upside down and moves towards the cat, which is not something we would like. So we are going to eventually stick with the left and the right option, and let's choose that. And let's play our animation one more time. The duck is approaching the cat, and they are meeting right in the middle. We achieved our first objective from our plan. Now we are going to go into the cat, and the cat moves up to the duck. All of the X and the Y coordinates look great. So now we want both of these to start at the same time, as I mentioned before. So we are going to add the green flag to both of the sprites at the beginning. So, and then now when we click the green flag, both of them are going to start at their respective ends and going to meet at the middle, which was first part of our project plan. This looks great. Now, we also want, according to our project plan, we want the cat to say rock, paper, scissors. So we are going to go into the looks option as we are in the cat's, in the sprite for the cat. And we are going to add something that says, say, hello for 2 seconds. So in that command, we are going to write, say, rock, paper, scissors, and exclamation, and for 2 seconds. And we are also going to say, let's say, the cat is going to, what would we like the cat to say? But first, let's test it. It does say cat ends up in the middle, says rock, paper, scissors. Now I'm going to add the say command, and in this case, the cat is going to choose scissors. So we added scissors. It's for 2 seconds, and we are going to ask the duck to choose rock. In this case, we are not really using the logic. We are right now making sure the first part of our project plan is implemented, because this is a very basic animation as a starting template. So we are going to do that. We're going to add a wait command for 2 more seconds, so that both of them, there is a wait time before duck says his option. Now let's play our animation. And you can see that in our project plan, we are asking at the end that the duck who will win, or whoever is the winner, would jump up and down after they win. So in this case, scissors, rock, the duck wins. So now we want to make the duck jump up and down. So for that, I'm going to look for a command which allows me to move my Y. So there is a command which says change Y by 10. In this case, I would like to change my Y by say around 50 so I can actually see the motion. So I'm going to change it to 50, and then I'm going to duplicate it and change it to minus 50 so I can see the duck jump up and then he comes right back to the ground. And let's see if we can add a repeat command to that, say repeat 10 times, so we can actually see the jumping up and down action quite consistently. So let's add the change Y by 50 to the repeat block. And in this case, we have the perfect. And now if we play, you can see that he would rock, paper, scissors, scissors, rock, duck won. So duck is going to jump up and down, but it didn't do that. It actually did it, but it's so fast that we cannot notice it. So we're going to add a wait command right after our change Y by 50. And we are also going to add a wait command right after our change Y by minus 50. So this allows for some motion to be seen by us. And we're going to put a wait command for 0.5 as opposed to 1 and then see the duck jump. So let's see. Cat and duck meet, rock, paper, scissors, scissors, rock, and now the duck should jump. And it's going to do that 10 times because that's what our repeat command is. So this is our very basic sort of project plan where the duck won and duck is jumping. We have two sprites. You can also modify the values by a little bit just so that you can see a little bit more smoother motion. But this is what I set out to do as a basic template for us to create a project plan, have some logical thought behind it, and then implement that project plan step by step. Now we're going to go to the stage. I would like to have some sort of a background attached to my rock, paper, scissors. So we go into the choice for backgrounds, and at the bottom you actually have a coordinate grid that you could add just so that you can actually see the motion, the XY grid, and it gives you a nice pixel count and an overview of the pixel. You could use that as a background. Um, in this case, I would like to use some colorful background with this. So let's look at what options we have. So we're going to go into the library again. And in this case, I could choose maybe a colorful city or a desert or a farm or something called the Jurassic, which has some nice colors. So I'm going to place my duck and cat playing their game right in the middle of that. So we have a nice little stage where duck and cat are playing the game. To make this game visible, obviously make sure your name is correct, and then you share the project by clicking the share button right here. Obviously, you can save the project by going into the file menu, but once shared, it's a good practice to write some instructions about your game and also to make sure your name is correct. It follows the norm. In this case, you can follow camel case, which is, writing the first letter capital. Having relevant names for your project is very important. You can always add notes and credits if you are inspired by someone's game that you saw, or some sort of make sure you give credits. You write some notes about it because that's just good practice. You can also add the project to a studio, or you can copy the link and send it to people as well, share it with people. You can comment, so you keep the comments open, or you can turn off commenting, which would be very helpful as well. And now, because I've shared this openly, you can also use this project as a template to begin discussing about project plans, so on and so forth. These are some of the options for the looks, but basically you have your project, you have your sprites, you can see some of the code that's in your sprite, and you have multiple sprites interacting with each other. So this is a as per our program, we have our project plan implemented in a very basic template. Now we are going to go back to our um, session, and we are going to look at the DLCS standards. DLCS stands for Digital Literacy and Computer Science Standards. So I want you to take you back to our presentation and quickly take a look at the alignments to the Massachusetts DLCS standards. In this case, we are looking at the algorithms, and this is for 3 to 5 grade levels. So you can see that with this project, we have started defining an algorithm as a sequence of instructions that can be processed by a computer. There was a recognition that different solutions exist for the same problem. There are multiple ways of designing rock, paper, scissors algorithm. Obviously, using logical reasoning to predict outcomes of an algorithm is very similar to having a project plan and then using logical thinking about how you would be implementing that project plan. It's very important individually and collaboratively to create an algorithm to solve a problem, which is you were posed with a problem and you created an animation. Um, Detecting and correcting logical errors is part and parcel of it, which also sort of goes back into the interactive debugging section, and detecting and correcting simple errors. As you had seen multiple times, we were doing it. Um, DLCS standards are very closely connected with the CSTA, which is Computer Science Teachers Association standards. So please go through those. We have links attached to those. It's an honor. Please enjoy the rock, paper, scissors template and build onto it with some algorithms and more of programming involved. Thank you so much. And this is Rashmi. Talk to you soon.